Example 2.3, we have completed part A and part B in the previous question. Now we go for part C. Give the sign of work done by the field in moving a small positive charge from Q to P. Okay. We have to move the charge, positive charge from Q to P. What is the work done while moving the charge Q to P? Work done by the field. I repeat, work done by the field, not by ourselves. Work done by the field. Which charge we are moving? Moving a small positive charge by the field. If I keep a positive charge at Q, I have to move it from Q to P. Work done. What is the formula for work done? Work done equal to force into displacement, or F dot D. FD cos theta. Here, I'm moving the positive charge because of the field. Field direction. Suppose if I keep positive charge at point Q, this is also positive. So there will be a repulsion. Force is away from the field. Away from the positive charge. That is P to Q. Force direction is from P to Q, away. The same arrow mark, right? Force is outward. Direction of force is outward. But in the question, it is giving the positive charge from Q to P. Movement is from Q to P. I repeat, force is outward, movement is inward. What is the angle now? Angle theta becomes 180 degree. Therefore, work done becomes FD cos 180. Cos 180 value is -1. Work done is negative. This implies work done is less than 0. But you should be very careful. You have to read the question properly. Question is work done by the field. Okay. Now, we'll go for the second part, that is part D. Give the sign of the work done by the external agency. Please note, previous case by the field. Now by the external agency in moving a small negative charge from P to A. I'm moving the charge from B to A. What type of charge? Negative charge. And what is the charge here? This is also negative. And you have to find out work done by external agency. Suppose if I keep a negative charge for any reason, that won't come inside, it will go outside. Correct? Because field is outward. External agency means I'm pushing the charge. In which direction? I'm pushing the charge from B to A. I'm standing here and I'm pushing the charge from B to A by the external agency. So, pushing the charge, applying the force in which direction? B to A. And what's the direction of the movement? Movement is also from B to A. Now, I hope it is clear. FD cos theta, theta value equal to 0 because force is inward, displacement is inward. Therefore, work done becomes positive. In other words, work done is greater than 0. Okay, we'll go for the last part now. Does the kinetic energy of a small negative charge increase or decrease in moving from B to A? Which charge we are moving? Negative charge. We have to move negative charge from B to A. Here, negative charge, if I keep at A, there will be a large repulsion. And while if you keep at B, repulsion is less because distance increases. Now, I'm moving from B to A means movement is against to the field. I'm not moving in the direction. I'm moving against the field. Negative charge moving against electric field B to A. Work done by the field is negative. Kinetic energy decreases. In other words, see here when a negative charge here, it is repelling strongly. So velocity is more. Here velocity is less. I have to move from B to A, then its velocity. Thus the kinetic energy decreases or increases. Velocity decreases, so kinetic energy decreases.